All right, here we go, 14.1. Now, the central case study behind chapter 14 is kind of an interesting one, and probably one you've heard about, because they're talking about this thing called bisphenol A, also known as BPA. So I'm confident you guys have heard about stuff like BPA free and this, that, and the other. This is what they're talking about here, is how safe is this stuff? It's been everything from, inside metal cans, it's part of bottles and part of plastic, but the big thing is that it mimics estrogen, is what it does. So that's why it's basically kind of a big concern. So we're going to be talking about kind of like toxicity and stuff like that and going on in this chapter. So starting on page 355, what I wrote here is environmental health and hazards. Excuse me. So there's what's stuff called anthropogenic, which is human caused. So when they talk about anthropogenic climate change, they're talking about human caused climate change, and not just something like the ice age and stuff like that that's happened in millennia past. So there are physical hazards like UV radiation, such as the girl getting the sunburn there. I am very, very used to sunburns because I'm definitely white and I lived in Hawaii for 9 years, so I've gotten lots of sunburns. We also got natural disasters, obviously, and we can go through a bunch of those, volcanoes and hurricanes and tornadoes and so on, so on, so on. Another thing we got, some hazards are chemical hazards like pharmaceuticals and pesticides and venom. Now, pharmaceuticals, one way I've heard of poisonous stuff is that everything is poisonous. It just depends on the dose. So that's why pharmaceuticals are in here. Because a pharmaceutical, based on the dose, can either be very, 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 very helpful, like penicillin and things like that, or it can be very, very, very bad if taken at high dosages. Moving to the next page, 356. It's going to be talking about some biological hazards. Now, this results from ecological interactions. And this is kind of honestly any kind of interaction that you have with anything else that's alive has a potential for hazard. So there's viruses that come from infectious disease, viruses cause infectious disease. Now, the vectors is kind of an interesting thing, especially since we're talking about kind of this in the era of COVID. A vector is literally somebody or an organism that transfers a pathogen. So, for example, let's say I already had COVID. I had COVID last March, actually about a year ago, right about now. So basically, I would be quote unquote immune. Let's just say hypothetically, I'm immune, but I can still carry the COVID pathogen, and then I can take it to somebody and get them sick. That's what a vector is. I am transmitting the pathogen from one organism to another. I'm like the pathway that it uses, kind of a thing. That's what a vector is talking about. Now, there's also cultural hazards. Cultural hazards basically like, in the culture, it's like accepted to do such things, or they're just simply readily available, like cigarettes and drugs. Occupational hazards as well. Like we were just talking about long line fishing and everything, like crabbing in Alaska and long line fishermen, they have one of the most dangerous jobs in the world. Another big cultural hazard is simply diet. There's a lot of fast food and there's all sorts of just kind of added preservatives that get into our food that's obviously not good for us. Moving to 357, I talk about infectious versus non-infectious. So infectious, very straightforward. It's contagious. Think of the common cold, think of the flu, think of COVID. It's contagious. It can also spread very easily. I wrote some examples down here. So like coronavirus or COVID, Ebola, the flu. You could write like the common cold if you want to add that to it. That's fine. Non-infectious, that's going to be a non-contagious thing, like based on genetics and lifestyle. So we were just talking about cigarettes. So your lifestyle, if you smoke cigarettes all the time, you're at a very high risk for lung cancer. Other things for genetics, you'll get diabetes. Genetics, you'll be more prone to cardiovascular disease. Like my genetics, I am more prone to skin cancer. Like all four of my grandparents had melanoma, which is a type of skin cancer. So after living for 9 years in Hawaii, I am really high risk for that. And that's again, going back to my genetics and my lifestyle. I have very, very fair white skin, and I lived in Hawaii. So like those are my choices that I did. So here on 358, I don't have a sticky note, but I wanted to point out this chart real quick, just to kind of talk about it. So you can see cardiovascular diseases, that takes up 30% of the, leading causes of death around the world, 30% or 31% is cardiovascular disease. Infectious disease is almost 17%. So basically, and you can see the other breakdown there. Then the infectious diseases, as you can see, then there's a smaller breakdown there. The chart I also want to point out is this one here, 14.4, because I know that it looks kind of funny. So I want to point out the caption as well. So it says, data from 1990 to 2011 is not directly comparable to data from 2012 to 2015. So that's why there's this line and there's a break in like the trend. That's pretty consistent, but that trend obviously is different. And you can see due to methodology changes implemented after collecting the 2011 data. So the method they used to get the data changed, so you can't compare, it's not apples to apples, it's apples to oranges in this case. It's similar, but there is a little bit of difference. So I know that chart was different, so I wanted to point that part out. All right, so moving to 359, talking about infectious diseases. So less than 20% of all deaths, but 40% of years of life lost. So again, let's go back to that chart real quick. We're talking about infectious disease. It's less than 20%. So you can see it's almost 17%. So that's less than the deaths, but the number of years lost. Like instead of living to the expected, age of 86 or whatever it is here in America, you're living shorter lifespan because of an infectious disease. It's not causing you to die, but it's causing your body to break down a little bit so you don't live as long. So how we can fight it? Clean drinking water is obviously one of them. That's a big push, honestly, around the world. Not only giving access to water, but giving access to clean drinking water. Sanitary bathrooms and plumbing. One of the things that kind of swing back up here to the diagram up there, talking about cholera. Cholera was basically just absolutely ravaged London in the 19th century, as you can see in the caption there. Basically, you can see feces, both animal and human, were ever present in city streets. The disease was spread through direct contact with feces and contamination of local drinking water sources. So, we need clean drinking water, we need sanitation in order to kind of fight against cholera. Obviously, having a nutritious diet, eating your fruits and veggies kind of thing. Getting education about a lot of different things, access to health care. All of those help fight the impact of infectious disease on us and on our culture. All right, moving to 360. So infectious diseases still threaten human life. So this 14.6 diagram, I'm going to swing up to real quick. Zoom out a little bit. So you can see the portion of the population, less than 50%, so on, so on, so on. Okay, so we're gradually improving sanitation for the world's people, but access in some regions remains inadequate. So we're talking about look at Africa. Improved sanitation, less than 50% of the population has access to clean sanitation. Same thing like in India. They're not doing very good over there. So their infectious disease starts to kind of run rampant over there if it gets going. So like I said, infectious diseases still threatens human life. So since our world is getting smaller and we are more densely packed together, disease transmission is very easy. So it sounds weird, but we've talked about feedlots. Think of, how densely we're packed into New York and LA and Beijing and London. We are becoming those feedlots. We are very, very, very densely packed in, so disease transmission can be really high. Moving to 361, I think I'll talk about toxicology. So this is the study of how poisons affect humans and other organisms. So earlier on, we talked about BPA, which a lot of people consider a poison. Toxicology is basically what kind of determines whether something is a poison or not, and the dosage of it. So toxicity, that's the degree to which a chemical substance can harm. And obviously, dosage is a key factor. You can take a small dose of one thing, but overdosing, people die. There it is right there. The dose makes the poison. So people are overdosing. That's what's causing it to be poisonous. And environmental toxicology is a growing field of study, which basically talks about how basically what we're producing is affecting the environment. We also got these things down here called the PBDEs. So these guys are fire retardant compounds that release into the air during production and life of a product. Now, these chemicals persist and accumulate in living tissue and has been doubling every few years in the US. So we talk about, you guys watch that 10 Americans, we found that in living tissue. So not only is it in humans now, but humans that are in the fetus as well. Humans that are in the fetus, that sounds wrong. Fetuses that are in the womb. We found that already. So these act as a hormone disruptor and can also affect our development, or also affects development of brain and nervous systems. So the hormone disruptor, basically your body's ability to kind of communicate to itself. That's the problem with this stuff. All right, so now 362 is kind of getting into 14.2, and so we're going to kind of overlap just a little bit on this. So first off, there's the cost-benefit analysis. So basically, toxicologists, what they do is they kind of do all this studying and all this experimentation, and then basically they find the results and they put the results out for the public to kind of consume. Then we need to make the choice on whether the cost is higher than the benefit. So like I wrote there, is the cost or harm to us in our world bad enough to ban something? Then we all have synthetic chemicals in us. It's impossible to avoid. And this is the thing we're talking about with the cost-benefit analysis. Is it bad enough? We think it's okay. So we're going to have some of the chemicals living in us. That's kind of the cost-benefit analysis. And this part here, this is that 10 Americans thing that we watched the other day. All right, leave some questions so we have stuff to talk about.